3-wire control is super easy to set up. The default drive is configured for 2-wire operation using maintain selector switches, and it's wired like this. To change to 3-wire control, just swap the selector switches with momentary switches and add a third normally closed momentary switch for stop control. We'll use input terminal P3 for that. These are the built-in digital inputs that come with the drive, the parameters used to configure them, and the default values. Using terminal P1 and P2 to control the direction is exactly what we want, so no changes needed there. And we'll use digital input P3, which defaults to an output inhibit, for the stop button, which is code 14. Let's do it. In the Product Insert Quick Start Guide, there's a diagram showing us how to wire this. I already wired these 3 switches to the drive as shown in that diagram. Now, if you don't have that guide, remember that you can always download it and all other documentation, including 3D CAD models, from AutomationDirect.com. I love that these Iron Horse ACN drives can be ordered with a built-in disconnect. That saves me time, money, and mounting space. Let's fire this thing up. We'll reset the drive to factory default so we know exactly where we're starting from. Right arrow to the drives group. Down arrow to parameter 93. Enter a 1. Select it. Accept it. Uh-oh. What's wrong? We have a BX on the display and all of the LEDs are flashing. Well, we wired a normally closed switch to input P3, which by default is the block drive output signal. This display is telling us the drive's output is currently being blocked because that input contact is closed. If I press that normally closed switch to open it, the drive stops blocking the output. So, let's change digital input P3 to be the 3-wire stop input. I can't do anything while this output block message is active. I could hold the button down to deactivate the block while I change P3, but another way to do it is to hit up arrow once, then right arrow to the input parameter group. Parameter 67, and change it to a 14, which replaces the output block with the 3-wire stop button. This changes the input terminals to latching inputs so they'll work with a momentary contact. Enter to select, enter to accept. Escape to the top level, and the output block is no longer active. Perfect. Let's change the frequency to something that's not 0, about 20 Hz. Enter to select, enter to accept. The default acceleration and deceleration values are really long, so let's change those so we don't have to wait on them during the video. Up arrow to the acceleration parameter, enter to accept, change it to something shorter. Enter to select, enter to accept. Up arrow to the deceleration, enter to select. I'll change that to something a lot shorter, and enter to select, and enter to accept. And escape back to the top level frequency display. Hit run. Nothing. Exactly what we expect because we told the drive to use these push buttons for control. Press the forward push button, and yep, we ramp up to 20 Hz in the forward direction. Notice that I'm not holding the button down. Press the reverse push button, and the drive automatically ramps down and ramps back up in the reverse direction. Perfect. And hit the stop button to stop. Well, that's all there is to it. By the way, if you need more digital inputs, the optional extended I/O module adds 3 more digital inputs, amongst other things. So check that out if you need more I/O. It just plugs in a drive here. Click here to learn more about the Iron Horse Nemo 4X drives. Click here to learn about Automation Direct's free award-winning support team, and click here to subscribe to our YouTube channel to be notified when we publish more videos like this.